What is the cost of downtime? I would like to start with a reality we are all facing in today's digital world. What you see on these slides represents the true impact of system failure. According to the Information Technology Intelligence Consulting, 9% of the enterprise are losing 300,000 plus per hour of downtime. Plus, 41% of the enterprise are losing between $1 to $5 million per hour of downtime. But these are just numbers. These are missed opportunities, damage to customer relationship, loss of productivity, and also a hit to the brand's reputation. But think like that. This is not just an IT problem. It's the business survival. Today, we're going to talk about building resilient systems, doing effective observability, and then at the end, we're going to show you 2 demos using GenAI. My name is Matheus Canella. I'm a senior solutions architect based in Sydney. And today with me, I have Jay, who is a senior cloud support engineer based in India. Jay.
Hi, everyone.
So what do we have for today's agenda? First, I'll go through the resilience foundations and best practice. And Jay will take control and talk about how to observe, detect, and investigate. So think about metrics, logs, and trace. Also, how to use the alarms and tools for you to investigate. And at the end, I'll show you a demo on how to do a full troubleshoot and then solve a problem with generative AI tool. All right, first is resilience foundations and best practice. Before we dive deep into technical aspects, I want to share you a personal, real story that demonstrates how resilience is critical for every technology implementation. So stay with me. 1 year ago, I decided to fully automate my house. And then, as you can see, that represented by the house. And then, because my house is not that new, I had to use wireless protocol. I couldn't use cables to connect to the lights or to the appliance. And then if you see, I had a wireless switch, and this wireless switch used a dedicated channel with specific protocol. I also had Wi-Fi lights, which use the Wi-Fi signal. So to have an idea, if you press the Wi-Fi switch, that goes to the home controller. The home controller will then decide where, which lights in the house we need to turn on. So as you can see, it turns on the lights. So as we're all busy, I had to do this after hours. And around 1 a.m., when I was about to finish, I just deployed an update, and then I went straight to bed. So during the night, the server failed. And then what happened is, the network used by the wireless switches also failed. And you can start guessing what happened, right? So the wireless switch became unavailable. But then my wife woke up 5 a.m., right? She needs to go to work and then, take a shower, prepare her breakfast. And then in Sydney, there's no sunlight around 5 a.m., so she relies on the lights, to do her stuff. But I was sleeping. And then she had no light. And you can start expecting that she was really, really upset. And you also may thinking, what happened to me at that time?
I think you're in trouble, Matthias.
Yeah, I was in a big trouble at that time. So what I want to do now is just go a little bit deeper in the conversation I had with her between, when she actually figured out that problem. So 1 to 2 minutes of that discussion. And you see how that relates to your day-to-day business. So she first wake me up saying, Matheus, what happened to the lights? I just woke up a little bit of nervous, 5 a.m., don't like waking up in the morning. Said, I don't know. Why? And then she just said, they're not working. All good until now, right? So it's expected as we discussed. But I want you to pay attention to the next thing that I said to her, which is basically what customers are doing nowadays to their customers. I just said, well, the SLA for the lights is 5 hours, and then you have to wait. But and then you see the next conversation, we're like, what? What is that SLA? Right? So, and that's what happened to a lot of business nowadays. When you have that type of issue, they don't know that SLA exists. She may be expecting the lights to be 24/7. Who would expect the lights, to have a failure or, a server that would impact that to work? But now, let's start bringing that personal story into how can we build on AWS. So first, if you see, my home controller was a single point of failure. When it crashed, every light stayed off, right? So if you think about this, we have the availability zones impairments. And then availability zones are isolated file domains with independent power, cooling, and network. But availability zones can also fail. And that's why it's important for you to think about having a multi-AZ discussion. So resiliency starts with redundancy across multiple AZs. So I want to talk about two servers. They're not the only one available for talking about multi-AZ discussion. And the first one is elastic load balancing. So imagine if one AZ fails or one node have an issue, elastic load balancing can shift the load to the next node in a different AZ if that's failing, like a health node. And it also applies to RDS multi-AZ. So imagine if you have an instance of a database failing in one AZ, it can shift the load to the other AZ. So the next one is I deployed things using ClickOps, which makes it harder to roll back. So that links to misconfiguration and bugs. So human error remains the major source of incidents. And the best defense is treating infrastructure like an application code. So no more ClickOps, right? In that case, we can talk about two things. The first one is using a repository to store your code. But we also talk about Cloud Development Kit, which is the CDK. So if you're writing your infrastructure, like your database, your servers, your network, all through as a code in a TypeScript, for example, you can then, once you deploy, it becomes a CloudFormation, but can also become a Terraform, and you can even use CloudFormation directly if you like. So the next one is alarm could have triggered my home lab recover before my wife discovered the outage, right? So I'm just clicking the next one. And that links to excessive load. So in that case, we can have, for example, outscaling. If you're having a spike in connections to your web server, right, that you can add and remove servers to cap with that load. And then not everyone is aware of, but we also have application outscaling. So you have the outscaling, as I mentioned, for your EC2s, but if you have Aurora read replicas or Lambdas or even DynamoDB, the application outscaling can also help you in that. And talking about Lambdas, it's important to think about managed service. Like Lambda, DynamoDB, or those servers can help you manage the requests without managing the infrastructure. And lastly, I never tested my Lightning Recover playbook until 5 a.m. So game days could have helped the family. So think with me. If you remember, the network for the switches was failing, right? But my wife was not aware that using an app could have turned on the lights. And that's why game day is really important. So you get the whole, in my case, the family, but you can have the whole company getting together to understand, if there's a bad day, what should I do? So in that case, I want to talk about two servers. AWS Fault Injection Service, which allows you to inject faults in your environment in a controlled manner. So you can terminate instance. You can isolate an AZ. And we also have the Security Hub. No, not the Security Hub. It's just hiding there.
Resilience Hub.
Yeah, the Resilience Hub. So in that case, you can import your application and run a report on that. And you can understand how your application will behave in case of a failure. All right, so this screenshot here represents the fault injection service if you open that in a console. And I want to highlight two of the services, not just those two, but you have many. As you can see, that page can have two pages there. The first one is the availability power interruption. So in that case, you can inject a failure in the AZ and see how your application behaves. And then the second one is the EC2 stress that you can do in a CPU. So you can simulate and stress in your environment to see how your application behaves. And then those faults that you can inject help you think about what happens if one part of my application fails. How is that going to behave? All right, I want to jump now in the other service that we mentioned before, which is the Resilience Hub. Before I show you a report generated by Resilience Hub, I want to show you the infrastructure that I ran the reports. So think about this as a single AZ, right? And in that single AZ, I have a single RDS, right? So a single instance of the database. I also have Elastic Load Balancer, outscaling group, and S3, but they are irrelevant for the reports I'm going to show you. So in that case here, once I import that application into Resilience Hub, I can generate a report about the infrastructure, and then I set up the RPO and the RTO, which is the recovery time objective and the recovery point objective, to be only 5 minutes. So if I run the report, you see that says it's unrecoverable, right? And you may start thinking, why it's unrecoverable? So if you look down the report, it's saying the database cannot recover within that 5 minutes. If you remember my infrastructure, I only had one database in one AZ. So if that database fails, you won't be able to recover. And that's where the Resilience Hub is really important to help you with your resilience posture. All right, let's change gears a little bit, because I don't want to forget to talk about trade-offs and risks. If you remember my use case, imagine if I want to have multiple servers, multiple wireless network, just in case I have an issue with the lights. Is that a cost-effective? And that's why you need to think about that when you talk about resilience. So if you have critical applications, it's really important. Okay, invest time, engineering time, and make that resilience. But if it's not a critical application, it's also important to understand the risks and take that in consideration. Right, before handing that to Jay, I want to talk about reliability improvement cycle. So first, resilience architecture from the ground up. We already discussed that. And then next is how to observe. So think about the metrics you can collect, what are the information you can get out of your platform. And then how you detect, right? So if you have that information, are you getting an alert? How you know that there's a problem with your environment, and then how you investigate, how you get to the root cause. And lastly, how you resolve, how you get this back to where it's supposed to be. But if you link that in a circle, that's why it's really important to get stronger and more reliable. So now I'll give that to Jay, who will continue with the presentation.
Thanks, Matthias. All right. So let's talk about observability. So I think it's a little hard to spell, but let's try to make it simpler in the next few slides. So how many of you are operating and managing microservices or distributed systems? Can I get a raise of hands? Yeah, quite a few hands raised, right? So right, that managing and operating these systems is really complex. There are multiple services that communicate with each other, like you have lots of microservices, your databases, maybe your queuing systems, all distributed and scattered, as you can see, like these blocks. And then they try to communicate with each other, and you might even not know when a new dependency is even added to that, right? So when something breaks in that system, you are just guessing that, okay, is it the service that has causing the problem, or is it the dependency that is failing, or is it the network? It can be DNS, or it's always the DNS, right? So yeah, so without observability, you are actually flying blind. So this is where we want to get with proper observability, right? So now everything changes. You now see the exact shape of your application, like how each and every service is interacting and how each and every dependencies are interacting with your services. And then if something fails, you are immediately able to understand where to look and what is breaking, right? But to get here, you need to track or monitor the right signals, right? So let's look at that. So to elevate your application reliability, you need to measure what actually matters, right? So let's talk about some of the key signals. So first, we always start with the business, right? So metrics like, let's say, revenue impact, the number of transactions or the number of orders that you process can be something that actually shows you some business outcomes or anything that relates to your business. So for example, let's say if your checkout service fails, you exactly know how many orders you are losing with your customer and what is the revenue impact, right? So this helps you to also drive your service level agreements with your customer, which is nothing but the promise that you make to them that, hey, my platform or my service will be up for, let's say, 99.9% of the time. And if you are not able to deliver that promise, you know exactly what is going to impact you. The next set of signals are user experience. So these are very critical because this helps you to understand how your customers are experiencing your application or, let's say, your website. So you can monitor the core web vital metrics like largest contentful pane, interaction to next point, or cumulative layout shift. So let us take an example of how this actually helps. So let's say if your metric, let's say largest contentful paint, is actually increasing from, let's say, 2 seconds to 5 seconds, that means that whenever a user is actually loading your website, it is taking a longer time for them to load your content on the website, and that means that they might abandon the session and then might go to somewhere else and drop from the platform, right? So that's why it is very important to measure the customer experience, like how they're actually using the application using these core web vitals. And these are standard metrics that you can always use and monitor. The next set of services are your service health metrics. So these are metrics such as the number of requests, right? About how the service is handling the request, or how many errors it is observing, or your latency, your P50, P95, or P99 percentiles, right? So always use percentile. Don't use averages, because averages can hide your bad customer experiences. So that's why. So measuring these will help you to understand like how your services are performing, and it will tell you exactly whether a service is healthy or not, right? So once you start tracking all these signals together, you can actually understand and completely understand how your reliability is working. And then finally, you have your reliability targets. So who here measures or SLOs? Can I take see a raise of hand? Okay, very few, but yeah, that's good. So I really want to dive deep into why SLOs are important for measuring reliability. So let's take a look at that. So when you're defining your SLOs, you always start with your end customers, like what they are expecting or what from your application or your platform. So you start with that, and then you decide or give a promise to them, like, hey, our platform would be up for 99.5% of the time. That's a promise that you're making. And if you're not able to meet that promise, we will give you, let's say, some kind of credits. So in order to then achieve this promise that you're making to your customer, you define your service level objectives, right? So this is an internal target that you take, and you work with your engineering team. So for example, this would be slightly higher than the actual SLA, let's say 99.9%. And the difference between your internal target and the actual customer promise will give you the error budget. So this is something will help you to deploy new features, new versions of your application, and still be able to make sure that the applications are reliable. But how do you know you are meeting these targets, right? So for that, you start measuring SLIs, or service level indicators. So these are actual metrics like latency, error, uptime. So you basically create SLO, which will track these service level indicators over a period of time, and then that will give you an understanding like whether you are able to meet the targets or not, right? So doing all this will help you to actually make your reliability measurable, and you can always track and improve it as and when you are not able to deliver your promises. So measuring these metrics or deriving these metrics can be challenging, because you might have to maybe, let's say, change your application code, add some libraries to it, create some custom dashboard. That's why we introduced Amazon CloudWatch Application Signals. So this is a tool that you can now start to use to basically monitor the health and performance of your system, and it will allow you to track your business goals as well alongside your system performance. So let us see what you get out of the box for application signals. So very first thing is, once you enable application signals, it uses OpenTelemetry auto-instrumentation method to derive or extract all the metrics and traces from your services, right? So you don't have to make any application code changes, and you can literally get started within minutes to get those critical metrics and traces out of your system. Second, once you enable it, it allows you to discover all your services and dependencies, and you can visualize them in a graphical way or a map view. And then it also gives you some pre-built dashboards. For example, what is the health of the services, how they are performing, how many faults they have, all these things into this dashboard. And finally, you actually track what matters, right? So it gives you the golden signals like your latency, error, faults, and then you also enable distributed tracing to get end-to-end visibility. And then finally, it allows you to natively track and monitor service level objectives within Amazon CloudWatch. So let us now see actually how application signal works. So this is one of the screenshots that I've taken from my sample application. So you can see here at the bottom in the highlighted section that we have 5 services that got automatically discovered once you enable application signals. And then in the same dashboard, you also get these widgets that will quickly show you which all services are observing some faults. So here you can see that there are few services, like let's say the front-end service is observing some 2.5% of faults. So now if you want to dive deeper into what is happening with the services, you can go and check this individual service health dashboard from application signals. So here in the center, you see all the golden signals, which I mentioned. And then if I just observe here, I see a request spike, which the service handled. And then at the same time, I see this spike in the number of faults that were observed on the service. So that means that there was some problem, and the service might be overwhelmed because of this spike. So when you click on this particular data point or point in time, you will be automatically taken to the correlated traces. So you can see here in the bottom right, you get the list of trace IDs or the traces that are correlated to this particular point in time. So now you can use these traces, and you can easily identify how the request traveled from one service to another, and then at which point the fault was introduced, right? So without you doing the correlation manually, this gets automatically added using application signals. So here is an example of an application map that you get once you enable application signal. So using this, you actually see how each and every services are connected and communicate with each other, right? So in the earlier part, I mentioned that, right? Like how it is critical for you to visualize and understand how each services are connected. So every node here, as highlighted, is your service that you are running as part of your application. And then every line here shows the dependencies which the service is interacting with, right? And again from here, you can go from this map view to the individual service health dashboard very easily. And finally, as we were talking about SLOs, so using application signals, now you have a native way to define and track and measure SLOs. So using this, you can easily see which SLOs are, you are able to meet the target, what is your remaining error budgets, so SRE team can keep tracking and monitoring this dashboard, and they can work with the development team if you are all, close to exhausting your error budget, right? So now we have got the right signals for our systems. So let us try to see how we can use these signals to quickly detect any failures so that we can act upon it, right, if something goes wrong. So in distributed systems, failures are inevitable, right? So you never know when a dependency or service will go down. But the real question is, do you know about it before your actual customers comes to you and complain about it, right? So that's why we need to detect these failures as fast as we can. And there are two approaches I just want to talk about. So let's start with talking about lagging indicators, right? So these indicators are basically telling you that something has already broken in your system. And then, for example, let's say we saw a spike, right, in the request. So when a spike hits, it elevates, let's say, your error rate, let's say from 0.5% to 20%, right? So that's a huge difference, right, from 0.5 to 20%, right? Or let's say your team, deployed a new version of the code, and that broke a critical service, and which then cascaded to further services which were relying on it, right? So once this kind of failures happen, you are actually firefighting, and your customers are already impacted through these indicators, right? So most of the teams are here, right? We all start with identifying lagging indicators, but then let's talk about leading indicators and how they can help. So leading indicators are something that will tell you that a problem is going to develop and it can be critical, so you can identify it before it actually impacts your customers. So things like, let's say, your API latency is gradually increasing, let's say, from 100 milliseconds to 200 to 300 over a week of time or over a days of time. So, or let's say your disk space utilization, very simple metric, right? But it can also grow up in size, let's say 5% day by day, and then gradually it will hit the limit, and there will be something going wrong with the service. So all these indicators, if you are able to identify, will give you enough time to act upon it, right? So you can, let's say, for example, you can scale your capacity, you can tune the performance, and prevent the problem before it actually hits your customers. So the key takeaway here is, as a team or as an SRE engineer, for example, you can start to evolve. We always start with lagging indicators because that is mandatory, but then we can try to shift left to these leading indicators as well in order to get more time to prevent any issues before they actually hits your customer. So yeah, so Amazon CloudWatch gives you some building blocks to detect both kinds of indicators. So let us see what they are. So we'll start with detecting leading indicators using anomaly detection, right, using machine learning algorithms. So the first feature we have is the logs anomaly detection. It allows you to basically surface any anomalies within your application log. So once you enable it, it's always on, and it keeps on scanning your logs to surface any new anomalies within these logs, right? The second feature that we want to talk about is metrics anomaly, right? So this is basically when you enable this on your CloudWatch metrics, it constantly goes and understand what is the past values of the metric, and based on that, it predicts the future values or the baseline behavior, right? And then if any metric goes above or beyond that particular threshold, it will show you as an anomaly. So together, they always watch your data, your logs, your metrics, and they are always learning based on the past data that you have. So let us see logs anomaly detection in action. So here is one of the screenshots that I took from my log group. So you can see here, once you enable log anomaly, you see that there are 3 anomalies that got detected. So let's try to focus on this particular one, right? So you see here that an unexpected pattern got detected with a severity of error, and then it see that the priority is also set to medium, and then this is the pattern that the feature was able to detect. And you can also see that how these anomalies are actually trending, right? How frequently they are occurring, so you can take action upon them. Next is metric anomaly detection. So here you can see that we have enabled metric anomaly on a standard metric called target response time, which you might be using in your load balancers. And then you can see this gray band here, which shows you the baseline performance or expected values. And then anything outside of it, either above or below, can be treated as an anomaly as well, right? So you can see here this particular spike can be used as an anomaly. So what you can do is you can create alarms on these metric enabled with anomaly detection. So you don't have to worry about static threshold, right? Because sometimes the metric can show some seasonal trends. So you don't know actually what is the right threshold, right? So using anomaly detection, it automatically understands what's the expected values, and then you can set an alarm. And it also helps you to reduce the alert fatigue as well. So Matthias, you had a customer that actually used this in real life scenario.
That's true. So I had a customer a few years back. So what they've done is they manage buildings. And then in the buildings, they install multiple cameras. And then what happened is when someone go across those cameras, it just triggered the motion and then sends the files to S3. And then the customer was like, how can I make that cheap to know if there's a part in that building, like if there's a lot of people going through that camera? So what they've done is they created a metric per camera because it's uploading files to S3, right? And then they used anomaly detection to actually note if there's a lot of people crossing that specific camera out of normal. So if there's a party in the afternoon that was not supposed to, then those files are getting uploaded more often, and then that's when the alarm was triggered by using the anomaly detection. Yeah, over to you.
So yeah, that was a good use case. So now let's talk about features that can help you to identify lagging indicators. So again, I want to talk about 2 features. First is logs pattern and compare. So using this, you can basically group similar log events into patterns, and then you can also compare whether these patterns are occurring in the past or not, right? So you can maybe select 2 particular time range, let's say from now to let's say last 1 day, and then you can compare what is the delta of seeing these kind of patterns to understand if something has drastically changed within your logs. Second is contributor insights. This is one of my favorite. It is very simple feature, but it is very effective. So what it does, it helps you to find top talkers, right? So whenever you want to understand like what are my instances which are actually degrading the performance, or what are the heaviest network users that are consuming the entire network bandwidth, for example, or what are my API endpoints that are actually facing the highest number of errors, you can use contributor insights to derive those information from your logs. So let us try to see them in action. So here is an example of pattern and compare. So as you can see on the top, I have around 27 patterns, but let's try to focus on some of them. So here is the highlighted area which we can focus. So one of the patterns that we have derived is showing us that there is an error called database connection timeout. And now what I'm also doing is I'm comparing it with the current time to let's say the last 1 day or last 1 week. So I can see that the delta is plus 252. That means that these are new events that got generated after, let's say, I made a new deployment, right? So this can exactly tell you what is the difference of this error, like how many times it has occurred, comparing it with the past periods, basically. So it can help you to quickly understand, like, whether the change that you've made is actually working or not. And here's an example of contributor insights in action. So what I'm doing here is I've created a contributor insight rules on my log group, and I'm tracking the, the payment failures for my customers using their customer ID. So so you can see that here there are a total of 12 unique contributors or 12 unique customers that are facing the failures, and I'm just showing the top 10 here. And here you can see that this particular customer with this ID is having the highest number of payment failures. And then on the top, you also get the logs getting converted into your time series automatically by creating the rules. So you can exactly see what is the error trend for this particular contributor. So now we have a detection mechanism in place that tells you that there is a problem, but then how do we go about investigating them and understand what actually caused it? So as a support engineer myself, I have been on a lot of incident calls with our customers, and there is a common pattern that I see, right? You start with seeing a lot of alerts that are going off. Most of them are noise, right, which doesn't tell you exactly what is going wrong. And then, the teams starts to dig in between, let's say, go and check one tool for metrics, maybe another for traces, and then check their logs. They're trying to piece together what is happening, right? They have all the data, but that is scattered across all these different tools, which takes them a lot of time to come to the final understanding of what is actually happening and why the problem is occurring. But imagine that at 3 a.m. you are an on-call, right? And then there is someone who is actually going and investigating all this information for you, and then when you actually go and check, it tells you exactly what happened. Wouldn't that be great? Yeah? So let me introduce you to Amazon CloudWatch Investigation, which is your AI companion that is built right into your CloudWatch console. So this actually helps you to automatically scan and correlate all your telemetry data that you have. It can be your metrics, logs, traces, your CloudTrail event changes, for example. And then it generates AI-powered findings and root cause analysis, showing exactly what happened and why, right? So what normally would take you around hours for investigating an issue, it will be able to be completed in just minutes. So you actually, going to focus on how to fix the problem rather than finding it, right? So let me walk you through how this actually works behind the scenes. So let's say, we start the investigation using features, and here is your AI buddy right there. So what happens is that once the investigation starts, the agent will start to first form the service topology. So what do I mean by that is that whatever services are related to this particular issue or investigation, it will try to build a map and see how they are interconnected. Next, it will then go and try to correlate all the telemetry data for all the services. It can be your applications, your services, or your AWS services. So you see that all the input gets scanned by the AI agent, like your metric logs, traces, and all the CloudTrail events. And then for all this telemetry data, it tries to detect the anomalies, like is there a spike or is there a particular trend that it is seeing. And it also does the pattern analysis automatically for you. So let's say there are some error logs that are being generated during the investigation. It will try to understand the pattern and show it to you. Once the entire process is completed, you will start to get the observations or key findings. And then based on that, the AI agent will create the hypothesis, which is actually the root cause analysis of what happened and why. And then finally, it also gives you suggestions about how to fix that issue. And then once the investigation is completed, generally we go and write down the detailed incident report, which is time consuming, and it will take a lot of time to generate that kind of report. So it also gives you an option to generate an incident report in standard format, right? So yeah, let's try to see that in action with a demo. So here is my demo scenario. It's a very, you can say, simplified e-commerce application that I'm running on a AKS cluster. So users are actually trying to post the orders through this particular API endpoint, and then they are not able to place the order and facing some errors, right? So now as an on-call, you have started to get paged, and you are going to investigate this using CloudWatch Investigation. So let us see how that works. So here's a demo for that. So I am currently at the SLO page, and you can see that the SLO that I created to track the order processing is currently unhealthy. and I'm almost going to exhaust my budget. So what I can do, I can click on Actions and click on Investigate. So this will open an investigation pane in the same window where you can provide a unique name to your investigation. It's kind of like you create a ticket and ask the agent to work on it, right? And then when you scroll down, you can just click on the Start Investigation button. That will trigger the AI agent to start the investigation. So now let's try to deep dive into what the agent is actually doing. So you can open the investigation that we just created. So I can just open that investigation. Yeah. So if you recall back the workflow that I showed you, right, the agent will first go and create a service topology and try to identify what all resources it needs to check. So on the top, you can see that it is analyzing, let's say, my Java Order API service or my Java Delivery API service, which we saw in the architecture as well, which are part of the demo. So what I can do, I can click on the agent queue, and you can exactly understand how the agent is going to investigate and thinking about how to proceed, right? So all the resources that is going to check, you can see that. And now if you scroll down, you start to get the key findings, right? So the agent has started to now investigate the telemetry data. It is trying to correlate it. And here, for example, you can see that it has found that the DynamoDB table is actually getting throttled, right? So we saw that again in our architecture that the orders are getting stored there. And now you can see that it is also trying to understand any anomalies by using the pattern and the anomaly queries to check if there are any anomalies within your logs. And it has found some of the anomalies as well. And here is a metric that it used to confirm that there are some throttling happening, right? So it's automatically checking all the kind of data that you have, with these services, and then giving you as a key findings. So while this is happening, what you can also do is that you can go and add your own custom note. So let's say you are a team and you are investigating together. So let's say if I find something important, I can share that context with my team by just adding a custom note, which will be part of your investigation. So I can click on Add, and it will add the investigation, right? So anyone in your team can look into it if there is some important information, right? So once this is completed, the AI agent will now generate a hypothesis once it has enough evidence of what caused the issue. So let us now take a look at the hypothesis that the agent generated for us. Yeah. So what I can do is I can click on this hypothesis, and it will open a detailed hypothesis information. So you can get all the information like, okay, what was the root cause summary, like what happened. You can see that the problem actually was the DynamoDB table throttling, and then exactly like the timeline of how the investigation went. And this is the service topology that I was talking about, that the agent creates a map view as well. And then finally, you see the suggested actions, that how you can basically fix this particular issue. In this case, as our DynamoDB table was throttling, we can obviously go and increase the write capacity on the table, and it will basically mitigate the issue. And you can also see some of the troubleshooting documents which it can suggest to you, which can help you to further investigate. So what I can do is I can maybe open the runbook that it suggested, and I can fill in the input parameters, and then I can try to increase the capacity right from the same console. So this was the demo that shows you exactly how the investigation works. You can see how drastically it reduces your time to investigate and get to a root cause much faster. So Matthias, as a solution architect, you might be interacting with your customers, right? Like how they can generate the incident report. Is this something that they are always?
Yeah, it's really important for my customers to be able to generate a report that they can send to the management so they can understand in details, what happened to the application. So what can we have?
Yeah, we also have that option now. So once the investigation is completed by the AI agent, you can just click on the incident report button, as you can see on the top. So once I click there, it will open the incident report console. So now what the agent is doing is actually collecting all the facts about the investigation, like what all details can be used for the investigation purpose. And then you can also review those facts that the agent collected. So for example, here what I can do, I can update this fact that how many total customers I have, how many of them got impacted. So you can tell your executive that, okay, this percentage of customers were impacted by this incident. And then once you fill all these facts, you don't have to fill everything, but few of them you can always edit. And then it will take few minutes to generate the incident report. So yeah, you can see here the report is generated for our investigation, which says DynamoDB write capacity issue. And then it will fill it up with all the information that you generally would add to your incident report, like what was the customer impact, what went well during the investigation, what are the next steps that you can use to mitigate the problem, right? Or what are the lesson learned about this investigation, right? All this information, it will automatically fill it up in this particular report, which you can then export and share it with your executives or stakeholders, right? So yeah, this is the report which we just created, right? So I'll hand it over to you now, Matthias.
Thank you, Jay. Let's now talk about how we resolve a problem. So what I want to do now is jump straight into a demo which use Kiro CLI. So you heard about Kiro IDE, right, which is an agentic IDE. But now I want to talk about the Kiro CLI, which you can run in your terminal. So before we jump into the demo and show you the application, I want to explain how the application works. So basically, you have a microphone, and this microphone will send a voice to a page, and that voice will be processed by a backend, which is an ECS, and then we also have a DynamoDB in a module. So once the voice comes in, it will translate that voice, we get into a text, and translate to a desired language, which will be broadcasted to multiple users, right? So you have two applications here. And then if you see, this is how the application works. So I'm going to create a session, so the first web page. So it's a test for reInvent. I'm going to add a description for that session. And then I'm going to select a language. In that case, it would be Portuguese, because I'm a Brazilian, so I speak Portuguese. And you see the next slide. So creating the session, you can see I can start recording. I'll jump into the other page where I can join a session, right? So I'm then selecting English as the output in the text format, and then I'll open the page. So if you see now, once the audio starts streaming, you're going to see from the original language to English as we selected language. And then here in that page is where you can see the two boxes in yellow. That's where the audio will go in and then broadcast the text out. So let's see that working.
Olá, vamos testar se essa aplicação funciona. Eu quero ver se ela traduz do português para o inglês.
So as you can see, I was speaking in Portuguese, and I got that translated near real time to the other side in English, right? So I heard to simulate here, just heard from a user complaining that the user cannot create a session, right? So you just saw that we created the sample, but the user just said, no, I cannot create a session. And then what we're going to do, we're do an investigation using Kiro CLI. So what I have here, my terminal, inside of the folder called platform, and then that folder contains the CDK. I've used the CDK to deploy the whole infrastructure, and I'm going to run Kiro CLI. So once I run Kiro CLI, it starts loading, and then as you can see, I'm running multiple MCP, so it extends the LLM by loading ECS MCP, the CloudWatch, the documentation, Playwright, which is an important MCP in that troubleshooting, and you see, and also application signals, as Jay mentioned. So that I'm also using Claude Sonnet 4.5, and then I'll paste a prompt now. So I'll clear the session, and then I'll paste a prompt for the LLM. So as you can see, I'm asking the LLM to go and open the page and trying to create a session. I'm not providing details where to click, how to click in the HTML, just saying go and simulate a session. I'm also providing details below saying do not change anything in AWS without my permission, right? Also below, I'm telling about the infrastructure. So I'm saying there's a CDK in that folder where you were loaded. I also am telling there's AWS profile called RIV, which give access to the AWS infrastructure, like Route 53, CloudFormation. And I'm also telling the LLM that where the backend source code is. So if you press enter, the LLM or the Kiro CLI, we start now thinking and trying to simulate that create session, right? So despite being recorded, at this stage, I'm not touching anything. So the LLM or the Kiro CLI is actually going through and trying to figure out how to create the session and trying to simulate the user. So as you can see on the screen, it's saying I can see the page, and then checking for the console logs. It's also waiting for the browser to finally load. and saying, oh, actually, I found how to create a session, and now I start populating the session with the details, like just a fake details, test session. I was going to select a language and trying to create a session. And at this stage, you can see that the session cannot be created, right? So when you saw the first time, you could create a session, you could translate, but at this stage, it's failing. So if I continue processing, now what CuriousCLI is doing is going to dive deep into the AWS infrastructure. So we'll be querying the AWS CLI to understand about the Route 53. Where is that domain pointing? What are the records used in that hosted zone? See, it's listing the resource there. And then you can see I found the DNS record. And then now it's going to go into the load balancer. Is there any health target there? Is it pointing to anything behind the scenes? So let's continue. It's going to the listeners. We'll check see if there's any 443 connections. Going to the load balancer. So it's describing the rules. So just continue. Yeah, going to checking if there's any health targets in the backend. And now it's touching the ECS. As you remember, I had the ECS as my backend. And then what it's saying is, I found an issue with your ECS. So let's continue the debug. And then, as you can see, there's a red message there. And Jay, as you work in the support team, what does the error mean?
So basically what happened, like the LLM tried to use a made-up cluster name in the beginning, but this was not existing, right? We had something else using the name with the cluster. So in the first place, it failed, but then it automatically understood that I need to go and grab the cluster names. So what it does is in the next call, you can see it makes use of the list cluster API call, and then automatically tries to list the actual cluster name. So it is doing it by its own and trying to list the right set of cluster that we have, basically.
Thank you, Jay. So we'll continue. So now it's listing the service. So we have a service, and then in the ECS service, we have the tasks, right? So it's describing the service now. And actually, it found the root cause. And then, as you can see, it's highlighting that the desired count in the ECS for that specific service is 0, which means we don't have a backend. So there's no container running behind the scenes. And then what CurioCLI is going to do now is going to provide me a root cause and how to go and fix the problem. So as you can see, give me a detailed information of what was the problem. So if you think about what the problem was, that's a screenshot of the ECS. And then the container is stopped, so there's no backend. That's what CurioCLI found through the queuing the AWS backend. So now what I'm saying to CurioCLI, go and then add another container, right? So change the desired account to 0 to 1, and then test it again. So CurioCLI is running a command, adding an extra container to that service. And then if you see, it's waiting for 60 seconds, but I just speed up the video just to avoid us waiting. But it's just waiting for the container to warm up, and then checking if now the container is health, and then starting again the same test you've done before to see if now you can create a session. Let's see if you can create a session, if it actually solved the problem. So we'll provide the details of the session name, similar to what I've done before. Select a language, and then create a session. Here we go. Here we go. So now it's able to create a session, right? So CurioCLI was able to go and then simulate a user, do all the testing, go into AWS, understand the whole environment, because I haven't provided, like, this is my ECS, this is where the task is. So it was able to figure out all the details, find the root cause, and once I provide a command, it just went there and then fixed the problem. So if you see, now we have a running container in the backend. All right, and then we're about to finish. I just want you to think for a second, what matters more in our use case? Is it the light? So if you see for my use case, if the server is down, but my wife could continue to use the lights, is it better? Or maybe the server was working without any problem, but the lights were not working. And here's where I want you to start to think about working backwards from your customer and understanding how critical is the application and defining with the business how to deal in case you have those situations. And then let's get the key takeaways for the day. So in the case we talked about backup, right? So in my case, I could have provided a candle. So my wife would be able to do organize her breakfast using a candle. I also could have organized a game day, and then the family will understand how to proceed in case of we had a bad days. Or, as Jay mentioned, we could have dashboards to understand how the environment's operating, create also alarms. So if there's an issue, I get alerted. Also, it's really, really important to define the SLAs, SLOs, SLIs, get the business together, right? I've seen a lot of customers where the IT defined all of those numbers, but they don't have the connection with their customers, with the business. And lastly, as we all talked about AI ops, I could have, for example, Alexa and say, Alexa, go and fix the lights for me. So I hope you all have enjoyed the session. One thing that I would ask you to do is, in your app, you should have access to the survey. It's really, really important for us because I do actually read all of this feedback, because that way we improve our next session. And then here's the call to action, so you can scan and learn more about what we discussed. Thank you.